Welcome to our final presentation for the Clue Game application project for Team Among Us. Over the course of this project, we've worked to create a multiplayer game with engaging gameplay, real-time communication, and a robust client-server architecture. Today, we'll summarize the journey, highlight the final deliverables, and provide a live demo showcasing the completed application. Here's what we'll cover in this presentation. First, a project overview, a brief recap of our project's goals and scope, value to the stakeholders, how the final product delivers on stakeholder needs, challenges and risks, the key challenges we faced and how we mitigated these risks, architecture, a brief look at how the system is designed and functions, features delivered, a walkthrough of the features implemented in the final version, and a demo, a live demonstration of the application. Our Clue Game application is a multiplayer game inspired by the classic Clue board game. The objective was to create a system where players could interact with the game board, move between rooms and make suggestions, communicate with each other via a messaging system, and play in real time using a client-server architecture. The project involved building essential functionality, ensuring smooth server-client communication, and delivering a user-friendly interface. The final product adds value to our stakeholders by meeting functional goals, delivering a fully functional multiplayer Clue game with real-time gameplay and messaging, engaging users, providing an intuitive interface and seamless gameplay that enhances the user experience. Showing a demo allows for stakeholders to see the final working product and how the game is to be used. We can also receive feedback from the stakeholders about potential developments that could be completed. In addition, we can ensure that they are satisfied with the product, building their confidence and excitement in this product. With the demo, we can ensure the quality and usability for users and demonstrate how to play the game. And finally, we can celebrate the success of having the final product. The project schedule was carefully designed to ensure timely delivery of all milestones while allowing flexibility to address unforeseen challenges. Let me walk you through the key phases of our project. Project planning. During the first few weeks, we focused on understanding the requirements, identifying key features, and designing the system architecture. This phase also included finalizing the technology stack and dividing tasks among team members. Minimal increment. In this phase, we delivered a working prototype with rudimentary user interface and basic game functionality. Key deliverables included player movement, a basic board structure, and server-client communication. This increment helped us validate the core architecture and address early risks. And finally, target increment. Building on the minimal increment, we focus on integrating more advanced features such as making suggestions and accusations, turn management, and a messaging system. This phase also included refining the server client synchronization to ensure consistent real-time gameplay across all players. We also had a UI redesign and technology pivot. As we transitioned to the final phase, we encountered significant challenges with the UI utilizing JavaFX and pivoted to using Python Flask. Recognizing our skills gaps in Java-based UI, we pivoted to the Python Flask for the front end. This required reworking parts of the system, but the team rallied to complete the redesign within the last few days. And the final deliverable. For the final increment, we polished the system, addressed bugs, and improved performance. Features like chat functionality and game state persistence were finalized. Throughout this project, we faced several challenges and risks, which we addressed proactively to ensure successful delivery. With a server-client communication, we established reliable synchronization between multiple clients, which was a complex task. We encountered issues with socket management and data flow, which required significant debugging and testing. For feature integration, we added functionalities like real-time messaging, game logic, integration, introduced complexities, particularly when coordinating multiple subsystems. With time constraints, we managed development and testing within that timeline which posed challenges, especially when unexpected issues arose. Finally, there were skill gaps in the UI development, as discussed previously. One of the biggest challenges we faced was the fact that all team members have a strong backend development background, but limited experience with user interface. Initially, the UI was implemented with JavaFX, but due to difficulties and lack of familiarity, we decided to pivot and rebuild the UI using the Python Flask framework in the last few days of the project. This decision came with risks as it required reworking parts of the application under significant time pressure. However, through collaborative effort and effective task delegation, we managed to get the new system up and running successfully. By prioritizing essential features, collaborating effectively, and maintaining clear communication, we are able to overcome these challenges and deliver a functional and complete application. Our Clue game application is built on a client-server architecture designed for multiplayer gameplay. The architecture is modular, ensuring scalability and maintainability. Here's a breakdown. Client subsystem handles player interactions, including movements, suggestions, and chat messages. Server subsystems processes game logic, manages the game state, and ensures synchronization across clients. Other key components are the clue board, tracks player positions, manages the game board. A server chat manages real-time messaging between players, and client handler, which facilitates communication between individual clients and the server. This design ensures a seamless multiplayer experience with real-time updates. As you can see, we have the back end and the front end, and the architecture has not changed from our minimal to our target increment. Our final deliverable includes the following features: player movement, where players can move across the board with real-time updates visible to all clients. They can make suggestions and accusations. Players can interact with game logic to deduce the solution. Real-time messaging. Players can send messages to each other during gameplay, enhancing communication and collaboration. And finally, game state management. The server synchronizes player actions and maintains a consistent game state across all clients. These features deliver a complete and engaging Clue game experience.
Okay, so we're going to show the target increments. Right now we have a GUI. We got 3 clients up. 1, 2, 3. And we also have the server running. People can create lobbies. So let's put, I'm just going to put host. Actually, that's probably better. I'm going to put admin for host. Lobby is going to be test. When this person, admin, creates a lobby, you can see here he's redirected to another web page. And he's in the waiting room. When other people refresh, they can see the new lobby. And then all they have to do is put in a username and hit join. You can see here it's automatically updating. And if Mike joins, you can see other people will see that Mike joined. Once there are enough players that have joined, you'll see that there's a new button, start game. This is only available to the person that owns the room or who created the room. And when he clicks the start game, everything, the board, the entire game, board game is like being set up. You can see here the username of each client, admin, Justin, Mike. You can see their cards. You can also see what character they're playing as, so Professor Plum, Colonel Mustard, Miss White. Okay, we can also see the board. We can see Mike is Miss White, and he's here in the starting area. Justin's Colonel Mustard, he's here. And admin is Professor Plum, he's here. We can also see the actions that each players have. Players can only do actions during their turn. So right now it's admin's turn, so he has all of his actions ready. And other players are not, it's not their turn for the other player, so they don't have any actions. We can actually see the turn order works. So if admin just does nothing and he just ends his turn, it's now Justin's turn, and he can just end his turn, and Mike can also end his turn. And we're back to admin. Admin can use any of these move actions to move around. If he moves up, he'll get blocked. If he moves right, he's allowed to. All right. And once he moves, he can no longer move until his next turn. So if he tries to move up or down into a room, like a conservatory, he's not allowed to. We can see Justin. Justin's right here. He can move left. And everybody else, all the other players can see that he moved left. Mike is right here. He moved down. And everybody can see that Mike moved down. Oh, I forgot to also show you the game logs. These are the game logs. You can see the history of all the movement. So admin moved from the hallway to this hallway. Oh, there's nothing special right now to show. Let's do a let's have admin move into a room. So if admin moves into the conservatory, you'll now see another button called the suggest button. If admin clicks the suggest button, he can do a suggest action to suggest other players of what might be in the case file. Now admin can suggest in the case file. So if admin suggests, let's say, a dagger and also Mr. Green. So let's say he suggests dagger and also Mr. Green. You can see here that Justin has a way to disprove the action or the suggestion. So Justin has a way to disprove the suggestion because the suggestion of Mr. Green with the dagger, Justin owns the dagger card, so he can select dagger. And you can see here the host sees Justin disproved my suggestion. Admin sees that Justin disproved the admin suggestion with dagger. You can see here, it's all logged. Only the suggester, which is the admin, can see which card, which is dagger, disproved the suggestion. Nobody else can see it. Yeah, nobody else can see that log. But people can see what was suggested and who disproved the suggestion. So everybody can see that it was Justin that disproved admin suggestion, but they don't know which card. If admin tries to suggest again, admin gets blocked because he already suggested this turn. So admin can only either accuse or end turn. Let's say admin end turn. Now it's Justin's turn. Justin can like move into the lounge. Let's say Justin moves up into the lounge. Let's try another thing with suggestion. There's another feature with suggestion. Let's say that Justin suggests Mr. Green in the lounge with a candlestick. Sorry, I messed up the order. Okay, nice. Oh, look, Mike has 3 cards that could disprove the lounge thing. So Mike, or as Miss White, has a lounge card, has a Mr. Green card, and has a candlestick card. Mike only has to select one to disprove the suggestion. So let's say Mike chose Mr. Green. Mike or Justin sees that Mike has disproven his suggestion with the Mr. Green card. Justin can also see it inside the logs. No other players can see it inside the logs, but they can see that Mike disproves Justin on what the suggestion was. And also, Mike can also see that admin could not disprove Justin. But everybody knows what the contents of the suggestion was. Let's test out movement of suggestions. So I'm going to end Justin's turn. Let's say Mike moves into the hall. So let's say Mike moves into the hall, and there's a suggestion on Professor Plum. Let's see what happens. So Mike has to move left. Now Mike is in the hall. Now Mike does a suggest. Let's say Mike suggests lead pipe and also Professor Plum or the admin. Of course, admin can disprove the suggestion. He has to disprove it with the lead pipe. But you also see the admin was teleported from the conservatory into the hall. So when a player does a suggestion of another player that's in the game, they are moving that person. The suggester is moving other players into their room. And I will end Mike's turn. Okay. Let's say that's admin who's now in the hall. We'll just end admin's turn for now. Let's say Justin does a secret passageway. So secret passageways do work. And on the secret passageway, Justin can do a suggestion after the secret passageway. Justin can accuse whoever he wants. Let's say he moves Mike, Miss White back to somewhere else. So he says revolver, and then Miss White. And you can see here, Mike was moved with Justin. Let's look at accuse. So let's say Justin believes now he has enough information to do an accusation. And let's say that he accuses wrong. So I'm just gonna put something random for Justin. Say Hall. Well, rope was disproven, so let's try, sorry, revolver was disproven, so let's try rope. And let's try the conservatory. And Mr. Green. Oh, the accusation was incorrect. Everybody can see that Justin's accusation was incorrect, and also see what Justin accused, or the contents of Justin's accusations, and what just happened, and that the accusation was wrong. But Justin himself can see the accusation's contents, so it was Hall, Revolver, and Professor Plum. I'm gonna do a little cheat. Okay. Hall. So let's say Mike does an accusation, but Mike gets the accusation correct. So let's say he gets lucky and it's Hall, he gets lucky and it's Revolver, and he gets lucky it's Professor Plum. And you can see here Mike won the game because he just got really lucky. Maybe he cheated and look at the case file. And everybody can see that Mike won and what was inside that case file. All right.